Okay, so let's look at acids and bases in this lesson. And let's talk about the properties of acids and bases. So acids have a sour taste, whereas bases are bitter. Acids and bases are both corrosive. Meaning they can help to break things apart. Acids are going to turn litmus paper red. Bases are going to turn litmus paper blue. And I remember this, B for base and B for blue. They are both electrolytes. I left this out. Let's go back up. They are both electrolytes. All right. Acids are going to react with metals to form hydrogen gas. And bases feel slippery. Have you ever pumped gas and got some gas on your hand and noticed that it felt slippery? The reason for that is because gas is basic. Same thing, bases are what we use in our cleaning products. So if you've ever done a lot of cleaning, all right, maybe you wanted to go out with your friends and whoever you live with said, you're not going anywhere until that bathroom of yours is clean. And so you went on a massive cleaning spree and spent a long day of cleaning, and you noticed at the ends your hands kind of felt slippery. That's because we use bases in our cleaning products as well. In terms of our litmus paper, we've written it down. We're going to look at a activity where we're going to actually see this. So we're going to kind of come back to litmus paper a little bit later on. All right, let's define acids and bases. Acids are defined as ionizing to form hydronium ions. So what in the world is a hydronium ion? A hydronium ion has the formula H3O+. So let's look at an example. If I have hydrochloric acid and I put it in water, now hydrochloric acid is a strong acid, so it's going to 100% ionize. What happens here is a hydrogen from the water comes over and forms, all right, with, I'm sorry, I said that backwards. I'm sorry, I said that completely backwards. A hydrogen from HCl comes over and joins with the water, leaving me. So if I take off this hydrogen, what am I left with? I am left with a chloride ion. If I start with 2 hydrogens and I add an additional hydrogen, I now have 3 hydrogens plus the oxygen. Now, if chloride is a negative, hydrogen has to be a positive because we know opposite charges attract. So if water gains a positively charged particle, it becomes positive. And this is how acids work. So let's look at some uses real quick. Phosphoric acid is found in soft drinks. It's also found in fertilizer for our yards and gardens, and in detergents. Sulfuric acid is found in fertilizer and in car batteries. All right, sulfuric acid is a really strong acid as well. All right, so it's not safe to mess with batteries, especially car batteries, because of the high concentration of acid in there, and it can get on your skin and burn you. This is another reason why, amongst other reasons, but one of the reasons why we want to get rid of batteries properly, because there's a lot of toxic metals in there, and then again the acid. Hydrochloric acid, this is our stomach acid. So the big fancy word for that is the gastric juice in the stomach. All right, and this is what, along with other things, helps to digest food that you eat. And then we have acetic acid, which is vinegar. Now, what do we notice about all of our acids? All of our acids start with what element? hydrogen. So if you see something that starts with a hydrogen, it is an acid. All right? No exceptions for this class. Bases. Bases are defined as the dissociation or ionization to form hydroxide ions. Now, we're not really going to distinguish between what does it mean to dissociate and what does it mean to ionize. That's something you'll distinguish between when you get to chemistry next year. Basically, dissociate and ionize here, we are breaking apart into ions, okay? Now, let's look at an example. Ammonia. Ammonia is NH3, and this is one of the main ingredients in cleaning solutions. When I put that in water, what happens? Water, a hydrogen from water, comes over and joins with the ammonia to form our polyatomic ion, ammonium. If I start with 2 hydrogens and I lose one, how many hydrogens do I have left? 1. And I still have an oxygen. And we learned in 2 units ago, OH is the polyatomic ion hydroxide. So bases make hydroxide ions. All right, so here we go. Let's look at some uses. NaOH. This is going to be found in things like lye, drain cleaner, and oven cleaner. Magnesium hydroxide. This is used as a laxative. It's also used as antacids. So if you have heartburn, all right, you may take an antacid, which has magnesium hydroxide, to help neutralize that acid. Ammonia is also used in cleaners and in fertilizer. So here's the deal. If it has an OH, it is a base. If it has a hydroxide, that polyatomic ion hydroxide, this is another reason I ask you to learn those polyatomic ions, because they have remained throughout the whole entire rest of the chemistry portion of physical science. We keep seeing these polyatomic ions appear over and over again. All right, so I know it was a lot of work for you to learn those polyatomic ions, but I had a reason for it. If you have this OH, it is a base. The other example of a base is ammonia. Now, ammonia doesn't have an OH, but we've already shown that it makes a hydroxide, so ammonia is also a base. Let's look at our strong and weak acids and bases. All right, strong acids and bases are going to make 100% ions in water. They are therefore strong electrolytes, because we looked what electrolytes were. Electrolytes are formed by ionic compounds. The greater the concentration, the more electricity being produced. So they are dependent on concentration. So if I have 100% ions, I have a high concentration. All right, lots of electrolyte activity. Some examples are going to be hydrochloric acid, nitric acid, sodium hydroxide, and lithium hydroxide. These are strong acids, hydrochloric acid and nitric. Sodium and lithium hydroxide are both strong bases. Weak acids and bases are going to produce few ions in water. All right. Whoops. Few ions in water. And they are what we call weak electrolytes. So they don't make 100% ions. For example, acetic acid. And we already took a look at acetic acid earlier in this unit, and we saw that acetic acid only breaks up into some ions, all right? The rest remains acetic acid, and then ammonia as well. This is a weak base. So acetic acid is a weak acid, ammonia is a weak base. Now, you don't have to know how to determine is it a weak or a strong acid. You just need to know the definitions, all right? You will determine and learn how to do this when you get to chemistry next year, all right? For now, I just need you to know those definitions. All right, earlier I told you we were going to come back to indicators. All right, indicators are things like litmus paper. All right, so we're coming back to this. All right, so litmus paper. Phenolphthalein is another indicator. It turns pink. Goldenrod, it turns yellow or red, depending on if it's an acid or a base. And then again, red cabbage juice. So essentially what an indicator does is it changes colors depending upon whether it is in an acid or it is in a base. And we're going to look at these indicators in an activity in far more detail to help us understand really and see with our eyes what indicators are, because seeing is believing. So pH scale. The pH scale is a measure of the concentration of hydronium ions, H3O+, and it is measured with either a pH meter or an indicator. So here's these indicators again. Okay. Now, our pH scale, 7 is neutral. As I go down and away from 7, those are our acids. So acids are below 7. Above 7 is our base. The further away I get from 7, if 7 is neutral, the further away I get, the more acidic it is going down. The further away I get, the more basic it is. So think about it in terms of like a logical thing. 7 is neutral. 0 is way further away from 7. Got to be more acidic, right? So we call things down at the bottom end here, close to 0, we call them strong acids. 6 is really close to 7, which is neutral. So these would be weak acids. And the same thing with bases. 8 is really close to 7. So it's close to neutral. It is a weak base. Whereas 14 is way far away from neutral, so it is a strong base.